Hi, my name is Rogelio Nochebuena, and this presentation has to do with the final project of the class, Managing Machine Learning Projects, that we're taking at Duke University, and our professor is John Reifschneider. The main objective is to demonstrate how to maximize the benefit of energy storage at utility scale utilizing machine learning. In this slide, the main objective is to demonstrate that A, there is a problem and we have a solution that can generate substantial financial benefits as well as others to the utilities and comes as a result of the reduction in prices for solar PV and wind projects in addition to a lower cost of energy storage systems. The machine learning solution that we presented is going to be utilizing supervised machine learning system utilizing that have level information as well as test data. And also the main objective is to give predictions on how the storage electricity can be sold at higher prices, which generates more profit for the company, but also how to improve the lifespan of the batteries. In this particular slide, we analyze the cross-industry standard process data mining and how it's used to achieve the objectives of our presentation. First of all, we can say that utilities can reduce the OPEX by more than 25% utilizing suitable machine learning systems focus on energy storage, and part of the solution comes from generating multiple revenue streams and selling energy at the highest prices that has been stored during the lower cost of electricity. The other thing is that we can sell the energy in the spot market and penetrate also the merchant market, but simultaneously we can optimize the energies, the life expectancy of the batteries. The information that's relevant is weather conditions, electric tariffs, energy consumption, battery stage of charge, etc. One of the most important things that we can do is to come up with a prediction model, and we start saying that uh, the prediction comes as a result of analyzing information and give us a forecast or related with electricity prices, consumption, and other things. It requires sophisticated uh, work, including the use of statistical methods and other things, including sophisticated algorithms that include supervised machine learning, neural networks, etc. They are the risks in the predictions, and some of them have to do with change in the environment. For instance, time series analysis that are used to make the prediction could change from time to time because in many ways we're using historical data. We can also use regressions model that also can be good to give good predictions. Is there a cost of being wrong? Yes. If our models are not continually updated, we run the risk of providing information that is incorrect, and that could improve our predictive capabilities. This activity requires for us to provide with forecasts that are accurate and also that can take into consideration changes in the marketplace. If we are not careful and we continuously track or model, we can run into problems with obsolescence, which are going to impact negatively the delivery of electricity as well as financial um, performance of the little more um, descriptive or financial or I'm sorry or machine learning model. And as you can see in the label data, we're taking into consideration energy generated, power consumed, the transmission and distribution data, the cost of the electrical tariffs, information related with weather, the state of charge of the battery, the prices in the spot market, as well as ancillary systems. In the label information, we put things like sell price, if we are going to be buying energy from consumers, or also if we enter into the blockchains. That information is included in the machine learning model, and if we use things like multiple regressions or other mechanism, we are going to be able to give predictions with respect to the price of the electricity in megawatts per hour. And if it's attractive, we can enter to the spot market in different modalities. That could be day ahead, hour ahead, 15 minutes ahead, or even enter into the merchant bank, because we can specify that we can deliver X amount of megawatts on solid basis. Our model has to be evaluated or validated, and in order to carry such activity, which is prior to the deployment, is of vital importance that our prediction be reliable and accurate. And for instance, we can be comparing the information that we have versus the real data on the real data on the continuous basis. That evaluation can help us to understand how the model behave on the stressful conditions. Some of the tools that we can use to evaluate the performance of the system include root mean square error that give us a set of predictions, including spot prices, energy consumption, and other things. Some of the problems that we can face is that the information that we use to train the machine learning model could be incorrect, that we are supplying the model with incorrect or incomplete data, that there exists some latency in the transfer of information or the collection, I will say the collection of information. That could be some data drift and other model inaccuracies. To minimize this discrepancy, we need to validate and refine the model on continuous basis. The models that are adjusted and recalibrated to enhance their precision. Continuous validation help us to ensure the credibility of our forecast, and that gives assurance to utilities about the prediction that we present, and give them can be the basis for make investment decisions. In conclusion, we can say that our machine learning model used for energy storage can give the utilities an increase in their OPEX by creating multiple revenue streams and extending the life expectancy of the batteries. this scheme also give resilience to the grid and minimize the possibility of blackouts. And the operators need to have services that maintain the stability and reliability of the power grid. We start with the hypothesis that we can anticipate peak demand periods that is based on weather, historical data, on real-time consumption patterns. Or analysis can be sustained by using some means like mean absolute error, root mean square error, and that help us to evaluate the accuracy of our predictions. If we encounter a problem, we can either decide to continue or to start all over again. But we anticipate that we don't have to go through that final statement. Our hypothesis can be refined, and that continuous validation is essential for to maintain our credibility of our predictions. Thank you very much.